Welcome to this video using the BeautifulSoup module. Now that we know how to get our HTML to parse, let's look at using the BeautifulSoup module to filter and query and organize all this HTML into data. In this video, we're going to take a look at using the right parser, because BeautifulSoup has different parsers that work slightly differently, and it's important to understand what you're getting into. We're also going to look at using selectors with BeautifulSoup and comparing some BeautifulSoup methods with the CSS selectors we've already seen in previous videos. Then we're going to look at BeautifulSoup objects and the sort of methods that we can call on them in order to cleanly and efficiently navigate through the HTML. We're also going to look at real examples of code and see how we can avoid bad practices. I will be using Python 3.4, and since BeautifulSoup varies based on the version you are using, I recommend that you also use Python 3.3 or above. You should also have pip installed because we will be installing different modules. Note that BeautifulSoup isn't entirely consistent in its usage and terminology, so to install, use pip install BeautifulSoup 4, and then when importing in Python, you'll reference the module as bs4, and then import BeautifulSoup. By default, BeautifulSoup uses the HTML parser that's native to Python's standard library. This is called html.parser, but we can use other parsers for different reasons. We'll be using HTML5lib. This is slightly slower, but it's a much more forgiving HTML parser that emulates more how browsers operate. Some websites have invalid HTML, and modern browsers are forgiving and pretty much figure out what it's supposed to be, and it will add missing close tags and so on. You can install HTML5lib using pip. To do a simple comparison of the two, we can see this HTML code here. I'm going to go from bs4, import BeautifulSoup, and then I'm going to compare the output from BeautifulSoup of this HTML with both parsers. Using the default HTML parser, we can observe we get the exact same HTML. No surprises there. However, this is incomplete HTML, and if it was provided to a browser, the browser would fill in missing tags. So let's compare using HTML5lib. Now provide HTML5lib as the second parameter. Here you can see that now the HTML that we're interpreting begins with HTML, a head beginning and close tag has been inserted, and as well the paragraph tags have been wrapped within a body tag. This is how actual websites operate, and so this is the parser that we will be using for the rest of the course. There are lots of ways to navigate the HTML using BeautifulSoup, but one of the more common methods you will see are the find or find_all methods. Here we can enter a single tag name, and it will return either the first or all of the tags of that kind. We could also provide a list of tag names, and the method will provide anything matching either tag. Alternatively still, we can specify the attributes such as ID or class, and it will return based on that criteria. Note here that since class is a reserved keyword in Python, we have to write class underscore equals buzz. With other attributes, there's no underscore. Different still, if you're a regular expressions whiz, you can provide regular expressions to the findAll method, and it will return the matches. Here, this code will return all tags with an ID beginning with foo. These are all common and entirely functional ways of querying the HTML. However, I find something personally a little inelegant about overloading the methods like this. And since we have covered CSS selectors, I think you'll agree that the next slide has slightly cleaner options. Instead of using find or findAll, you can use the methods select or select1. This allows us to do the exact same queries and get the exact same results as the previous slide, but with much more concise and clear queries. Note, however, that not all CSS selectors supported by a browser are supported by BeautifulSoup. Let's again return to the Python console and walk through some of these examples. We start by importing the module. Then for this example, I'm going to use longer HTML code. Then from this HTML, which I've just entered as a string, but from the previous video we saw that we can request this HTML in multiple ways. Then using the BeautifulSoup method we imported above, we create our variable soup, and we say the BeautifulSoup is that HTML, and recall the parser we are going to use is HTML5 lib. Now soup is a queryable object using the methods we saw in the previous two slides. So let's compare the different methods and see what we get. So we can do soup.findAll and provide a tag name. Alternatively, we can do soup.select and provide a selector, which in this case is just the tag name. Here you can see that the two methods return the same list of tags. Let's look at another example. Here we can do soup.findAll, and now we're going to provide a list of tags. th for table header and td for table data. Again, the same query can be achieved with soup.select th td with a comma in between. Another example still is when we specify an attribute. So we can do soup.findAll, where the class, and again, notice the class is a reserved keyword, so we put an underscore, where the class equals buzz. As before, the same query can be achieved with soup.select.buzz. And for our last example, I'm going to import re for regular expressions, and we can do soup.findAll, where the ID is the regular expression begins with foo. We can say soup.select, where the ID begins with foo. And these two queries return the identical contents. I'm making a point of this not to show that find or findAll are incorrect methods. In fact, functionally, they're exactly the same. But if you can develop and debug your queries in the browser, then just port them over to your Python script, you will have an easier and faster workflow. Additionally, CSS selectors are widely supported, and there are lots of good resources online for figuring out how to use them because different languages use them. So don't limit yourself to just the capabilities of a single module. However, unfortunately, this advice does come with an asterisk because, like I said, not all browser-compatible CSS selectors are supported in BeautifulSoup. For instance, the query soup.select p first of type, which of course would mean return the first element of this type, is not a pseudoclass or a CSS selector that is implemented. However, like the error notes, nth of type is a pseudoclass, or let's stick with the term CSS selector, that you can use. So instead of first of type, you could do nth of type 1, as in get the first. And that would work. Now it's very important to note that the objects that these methods return are not simply strings. They are BeautifulSoup objects, and they have lots of very helpful methods and properties associated with them. These allow us to very easily move around the HTML and select tags relative to other tags. These methods are all fairly self-explanatory. To investigate these in action, let's go back to our previous example. In this shell, I still have soup loaded as the HTML that I provided before. So let's set p to be a variable that's soup.select1, which means select the first. And this is the example we saw before, where ID begins with foo. And let's take a look at that p. So the properties of p are quite extensive. There's lots of find siblings and find previous elements and so on and so forth. But let's start with looking at the find next sibling. And we can see that the next sibling is just the next tag on the same level, except you can see that this div has more tags nested inside of it. So we can look at the children, or the contents of this tag, by going .contents. And note that the contents of this tag aren't only its children, but also its text content. You can see world is a string, and then the div nested within this is a BeautifulSoup object. I point this out because this is slightly unexpected behavior, especially when it comes to the children property. People expect children to not include the text content, but rather only include the BeautifulSoup object. Now, children is a list iterator, but if I cast it as a list, you'll see that again, the children include just the string. So you'll want to be careful when iterating over children to make sure that you're iterating only objects, not just strings. As far as the attributes or properties of a tag, these are within a dictionary, and the dictionary is under tag.attrs, A-T-T-R-S. Note that with tag objects, all tags have attributes, and these are in a Python dictionary, so you can access these attributes like a normal dictionary. However, note that the typical method of indexing a dictionary with the square brackets, if the attribute doesn't have the given key, you will get a key error. So it's safer to use the .get method, which will return a none if the key doesn't exist. It won't throw an error. It's also worth noting that these properties all have both read and write permissions. For the most part, you'll only want to be reading, but writing can be useful to eliminate unwanted data, as we'll see in a future example. Once again, from our previous example, you can see that we have a dib object stored in this variable p, and we can find the attributes of this tag as a dictionary with the p.attributes. Take note here that since a class attribute can have multiple values, the class key corresponds to a list. As I said before, all of these attributes are both read-write permissions, so you can create new attributes as you would a typical Python dictionary. My main last point here is a word of warning. Please don't get lazy and forget your CSS selectors. Do take advantage of these. They're clever and quite powerful, and there are many good resources that will teach you how to use these to their full potential. More generally speaking, there are lots of good tools for web scraping and navigating the HTML for you. If you end up writing a lot of Python that's manually checking strings and playing around with list indices, you're probably going down the wrong route. I'll give you an example of the sort of code that is widespread among novice web scrapers and Python coders who haven't taken the time to understand how websites work. Unfortunately, very often I'll see code like this. So if I run this, you'll see that that's the result. And it's very, very likely that what this person was trying to do was this, which has the exact same function. So if you ever find yourself writing too much Python, try to realize that there's probably a better solution. So thank you for watching. In the next video, let's start putting this advice to use, and we'll walk through an example parsing Wikipedia.